it tells me that PQS is equilateral. Who can remind me what equilateral means?
They're the same.
All the sides are the same, right? They're all equal. So PQS, those three sides are equal. Because that's the definition of an equilateral triangle. Okay, we also know that those two angles, so I'm going to label these with S's. Okay, then we know that these two angles are congruent. And we know that these two sides are congruent. So if we spell it out, we know that these two triangles are congruent by SAS. It's a sassy triangle. SAS. Okay. So today we're doing 3.4, which is a backtrack from yesterday, right? Yesterday we did 3.5, which was HO. Okay. Today we're doing AAS and ASA. So in total, all the things we have, which are all the possibilities, we have SSS from the very start, right? Then we had SAS. And then we have these two, AAS and ASA. And then our exception to the ASS rule, which is HO. So we have 5 in total ways that we can determine if triangles are congruent. So these are our last 2 today, and we will have our test next week on Tuesday. So I have Monday to review, Tuesday to test. All right, so the ASA postulate is 2 angles and the included side of one of the triangles is congruent to the other triangle. Okay, so the 2 angles and then the side that's in between those 2 angles. So these 2 angles and the side that's in between. That's how we get ASA. Okay, the AAS theorem is 2 angles and the non-included side. So 2 angles here and the side on the outside of those 2 angles. So the 2 angles and the side on the outside of the angles. Okay, so then our proof skeleton, show that 3 corresponding parts are congruent, then determine from the diagram if it's SSS, SAS, ASA, or AAS to prove the triangles are congruent. All right. Zoom out. Okay. So we are given that AD is parallel to EC. So AD is parallel, that's what those 2 lines mean, to EC. Okay, you can see that by these little triangle things here. That means that those 2 sides are parallel. Okay, it also tells us that BD is congruent to BC because that is also given to us. Okay, then it says that ABD and CBE are congruent. So ABD and CBE are congruent. Why? It didn't tell us that they were congruent, but what type of angles are those? Yeah, vertical angles. So the vertical angle theorem says that ABD and CBE are congruent. I forgot to label my side with S. So currently we have an S and an A on both. Okay, and then it tells us we're going to use alternate interior angles theorem. Okay. So alternate interior angles, I can do it either way. I could say that angle ADB is congruent to BCE. So angle ADB is congruent to angle ECB. Okay, it just matters that D and C are in the middle there. Okay, that's because they're both inside our parallel lines and on alternating sides of that transversal right there. Okay, so that's another A. So if we were to label this out, we have two angles in the included side. So it would be ASA. Because the side's in between the two angles. Any questions on that one? Okay. So, it says to complete the following proof, given the diagram, prove that JKL is congruent to NML. So, the first thing it tells us that JK is congruent to NM, okay, because that is, what's our reasoning for that? Given. Okay, what else are we given in this case? NML. So, angle NML is congruent to what? Perfect. So, angle NML is congruent to angle JKL. Alright, then it tells us to use the vertical angles theorem. Okay, where's my pair of vertical angles? In the middle, right? So we have JLK, angle JLK, and what other one? MLN. So big thing, you just need to make sure that L's in the middle of both of them to get that angle mark where we want it. Alright, finally we can prove these triangles are congruent. Let's label our angles and our sides. Okay, so in this case, we have two angles in the non-included side. So it'd be AA, then S, if we read it in order. So AAS. So since that side's not in between the two angles, it is not ASA. It's on the outside of the two angles. So we write it after the two angles. Alright, on these ones, you are going to tell me whether these are congruent or not. So you're either going to write congruent by blah 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 or NEI for not enough information. Those are your two options for A, B, and C. Try it out. I'll give you a couple minutes. Alright. So looking at this one, I know that these two angles are congruent because it's given to us, right? Gives us those angle marks. We also know that these two sides are congruent. Is there anything else from the diagram that we can conclude are congruent? Do we have any shared sides? Not on this one. Do we have any vertical angles? We do. So this angle is vertical angles with this angle. So therefore, we are congruent by what? AAS. Good. Because that side's on the outside of the two angles, not the included one. So it's AA, then S on the outside. All right, looking at this next one, we have this side and this side are congruent. Are we given anything else? Yeah, the shared side. So NP is congruent to NP. Is there anything else? No. So we only have two S's on both, so there's not three corresponding parts. So this is not enough information to say that they're congruent. All right. Then this last one. So these marks, remember, mean that they are parallel, not congruent. So since these are parallel, we can say that the alternate interior sides are alternate interior angles are congruent. So you have that pair there, 1 and 3, and then 2 and 4 are also congruent. Okay, is there anything else that we can say is congruent? I heard someone. Shared side. Where's our shared side? In the middle, ZW, right? So since that is a shared side, that has to be congruent to itself by the reflexive property. Thank you. Okay, so then if we spell it out, S is in between our two A's. So this is congruent by ASA, since the side's in between our two angles. Okay, and then if you forget how we do these, I would write vertical angles and the reflexive property so that you know. And alternate interior. That way you know where we got all that information from. Alright, bye recording.